Shall I stop sharing?
Yeah.
Okay.
Anyone having any question?
Yeah, I
Then,
think it's clear now. I think
yeah.
it's clear now. I just got it.
Okay, I think Mr. Kartik, we can start. Or
I think there's an echo happening. Is everyone else facing the same issue?
no.
So, good morning, good evening. Welcome everyone to the second week or day. Okay. So, sorry, I think there's some audio problem for me, I think so. I'm just checking it. Just give me 2 minutes. Just once. Extremely sorry. I think there's some system issues out there that we have sorted out. No, welcome everyone for this day 2 of Intro to Cybersecurity and Internship program. Yeah, so this week we are going to be looking up and changing gears. And if you could see the last week, we spoke more about what are the basic principles and things about what is CIA, what are the problems that we face, and what is attack vectors, and what are those are the basic things that we need to know in cybersecurity. And that was very important for us, right? So to understand what is happening in the coming 3 weeks, we need to have some kind of a fundamental approach to our process for that. And that we have done with that. And people who have missed those sessions is not an issue with you guys. So the way we'll be going up will also be brushing up a little bit of those processes as well, or the concept that we spoke about out there. Right. So today we are going to talk about very important parameter that we use nowadays. That is, how do you do verify that, right? So how do you know your system or your application is safe or not? And that process is called security testing, right? And this is very much similar. Security testing can be taken to very much similar to like your car testing, right? So your automobile, they will come up with the telling that this is secure. There is an airbag system, it is working, and it is all kind of a security feature is there. But how do you know it is working as intended, or there is some modification or some issue with that? Best way to know that is to crash the car and see how the car behaves, or your automobile, see how your automobile is behaving. Then it is going to be quite easier for us to know whether it's working or not. Similarly is what we do in an application as well, right? There are different stages to that. At the same time, we'll also see how testing is actually important and how we are using this kind of a logic or concepts after we get from the testing into securing our infrastructure. Right. So today's session we'll be talking basically into three sections. So one is going to be vulnerability assessment. We'll see what is an assessment basically is about. Then we'll go into penetration testing, or AKA hacking part. And then we'll see how we are using this process into and securing the process out there. Right. So before we go, right. So when you look at the course section, right, what are the, let me go to next slide. The 4 weeks internship program that has been divided, it's basically it is more focused on a job process, right? In today's world, what a security engineer is supposed to do in an organization is basically it's focused on that. So in a penetration testing and infrastructure security, we are more into testing and checking for security as well. In a DevSecOps, it is much more into that, and it is introducing security at an earlier stage. And we see cloud security is basically how do you secure your cloud infrastructure, because almost all devices or applications we are running today are based on cloud. So this is very much the process that we will go. So week 2 is what a penetration testing and infrastructure security is about, right? So this is where I predominantly have worked in, right? I also have supported DevSecOps in a lot of organizations. We do consult them for that. But on my day-to-day activity, what I'm doing is that I'm basically a penetration tester where I hack for the companies, right? But let's look from an perspective, from an organization perspective, what are your duties as a penetration tester? And then we'll see what is the process that we're going to follow. Predominantly, a lot of clients who do come to us, there is a compliance requirement for them, telling that the application need to be tested for that, right? Most of the time it is in financial company where they have a requirement that their application should be tested once in 3 months for sure, right? They do come to us with an scope, which is very much important, which is tell what exactly to be tested, and we cannot test anything beyond that part. Scope is predominantly an IP address of a server or a device or a domain name like google.com or facebook.com, or it could be kalkey.com. So they're going to give us a domain under which we can test, and those things will be there. And we are going to start testing the application, right? Before that, there is some kind of an information given to us, and we'll identify the vulnerabilities in that particular application, predominantly based on the number of functionalities in that application or how big the application it is. A testing would go on from 3 to 5 days to, if it is a medium size application, and can go up to 10 days if it's a large application. Or it could be a continuous process if it is a very large monolithic application like a core banking software, because every week they're adding new features to that. And based on that, we are going to do that part. Once testing is done, once we have identified the vulnerabilities, we will create a sample report, and that report is sent to the client. And once client fixes it, we are going to come back and recheck whether the vulnerability is fixed or not. Yeah. You also work at a different level as well. You also work as a design engineer as well for the large of organization, where you're initially, when the project is being planned, when the design phase of the project is going on, you're going to sit in that team as well as a security engineer or a security architect, and you're going to tell what are the security features should be there on the point of design phase itself, so that it is not going to be an issue after the application is being built. Right. So let's dive in. Let's dive in. What are the different things? Right. Any security process is incomplete. You can't understand a security without understanding the CIA triad, which is the core principle of cybersecurity. Right? It talks about confidentiality, integrity, and availability, and all three are very much important. Confidentiality is confidential information should not be shared with unauthorized users. Only authorized users should be shared. Confidentiality, we can give it in what do you call it? It does not have to always mean it is an IT related thing or a cyber related thing. It can be done in any way, right? Let's say you're having a diary and you're writing your personal notes in the diary. If a person whom you don't want to read the diary is reading the diary, it can be called as a breach of confidentiality, right? That is what basically is about. It is as simple. It can go to that level as well, right? So next is going to be the integrity check. Integrity check basically deals about what you mean, making sure the data is not modified, right? There are two places where data can be modified. That is data at rest or data in transit. So meaning when the data is stored in the hard drive or some kind of information stored in a database, no one should be able to make modifications to that. Or when the data is being moving from one location to another location. Let's say when you're browsing some kind of a website, the data is moving from your browser to the server. Someone should not be able to capture the data and modify that. Right. Simple example we can think about is someone modifying your phone number in your banking account details, right? Or someone modifying on the transit the account number to which you are going to transfer the money for. Right? If someone able to capture that data and modify the account number, they can easily divert that money to their own bank account. And these are the things that happened in the past. Right now, it is more secure. Chances of it happening is very less, but still, as an example perspective, when we are modifying data, it is going to be there. Modifying or integrity does not always mean changing the data. It can also mean deleting the data. Right? That is what basically an integrity is about. And the final one is availability. Availability is something what we can tell is it is predominantly an attack vector where you're not losing any data or you're not losing any kind of an integrity of data is not compromised in any way or modified in any way. But here we are making sure that a legitimate user is not able to access a particular service. Right? It could be multiple things. A server is down, how to make a server down. Because in a confidentiality and integrity, what happens is that I can compromise the server. I can read the data inside the server or I make modification to the server data. But in availability, I will get the server down. There are multiple ways of going about it, right? And it is not only a server, right? We can do a lot of something called as a DOS attack, where we are sending a large amount of requests to the server in a very short span of time, right? So I remember when we tested on one of the Middle Eastern banks, they wanted us to test for that. So in the first case, what we tested was about 20,000, right? Packets per second that we flooded it, and the application was able to handle it quite easily. Then what we thought, let's add one more zero to that, right? So we sent around 200,000 packets per second, and I think that was an entire day application. Testing was supposed to be done on 3 hours, and testing got over in half an hour because after once the packet reached a very high number, the server crashed immediately. It could not handle the load, and the testing was over for hours. That is one way of going about it from a server perspective, right? Availability can also be compromised from a user perspective. Some of the cases where we have seen is that when some user does not want a particular user to be able to access their website or application, what they do is that they'll take their ID and in the table, in the web application, they will enter a wrong password wantingly for multiple times, right? In certain applications, what happens is that you might have seen in your corporate network, when you enter the wrong password multiple times, it is going to lock your account and you'll have to reach out to the administrator and it is going to delay your activities. And that also can be taken as a loss of availability. Any kind of an attack you take in cybersecurity, right? There will be a lot of attacks that are there that will all come down to either compromising one of these principles or all of them principles or multiple principles of this, right? Any attack you take, it will always come down to this. There's one more thing that we need to understand is AAA, authentication, authorization, and accountability or accounting, right? So here what is going to happen is that in authentication, we're just making sure that only non-authorized users are able to log into an application, right? So this basically means you are verifying yourself, right? And you're checking, you're showing let's say you're logging into Gmail. When you enter your username and password, Gmail knows who is the person who is logging in, right? So how was there are three ways of authenticating yourself. That is going to be what you have, what you are, and what you know, right? So what you know is nothing but your password, because the password is always in your brain or written in somewhere, but that is going to be basically that password based approach. And what you have is a token based approach. This is basically is something like your access card in your company and things like that. So where you're having a physical device from which you are going to authenticate yourself, right? When you swipe in your ID card in the company entrance, it also takes up your attendance as well as verifying whether you are actually employee or not. There, by swiping the card, you're authenticating yourself to the company entry system out there. And what you are is basically your biometric, right? Your face recognition, your fingerprint scan, what we use in mobile phones these days is basically into that process. Authorization is basically about, you know, once you're inside the system, it does not mean that you have to have access to that, right? Once you're authenticated to that, once you're authenticated to the Google Gmail server, it does not mean that you can read anyone's email in all the users who are there, right? You should only be allowed to read your own mails. You should never be allowed to read other mails. So making sure that activity is happening is that it is authorization check, meaning it is checking whether you're authorized to read that particular mail or not. So for instance, someone sends you a mail and you're either in the CC or BCC, blind CC, it is going to check. So that is checking is there authorized. You're authorized to view that mail. Only then you'll be able to read. If you're not authorized, it should block for that. Right. And accounting or accountability is a very important aspect. This is basically, it usually happens not from an attacker perspective. It is usually happening from a disgruntled employee or a negligence from the employee as well, right? They might do some action or they might they might delete a file or a very important file or thing. They might reject telling that they have not done it. This happened for me about very long time back when I was working for a company called Wipro. They were running a SAP server and there was a particular amount of customer data. I think it's more than about 500 or 600 customers. A particular bunch of data was deleted at once. And we tried to asking out everyone like what happened, who deleted anything. That the person who deleted it did not come up until that he deleted by accidentally. But in the meantime, what happened was SAP server had an option to check which ID was used to delete a bunch of data. And we were able to receive the log files and we got to that person. Then he confessed, but we were able to recover that information as well. But what if that person did not, we didn't have that information. We didn't have that accountability who did what, right? It would be very difficult situation. That is why it is always important to have some kind of an accountability into the processes. Yeah. So this is all things are important and these are the fundamental blocks of your cybersecurity. Whatever the activities, it may be biometric, face recognition, it may be advanced encryption standards that we're using, and whatever the security complex it's going to be, you may be using a supercomputer, anything. It will always come down to these concepts. CIA and AAA is what exactly is going to be there. And anything is going to be part of this. There's always a variation to this, but all the time it will be here itself, right? So in security, now we'll be looking at the, the main part, the security testing, what exactly it is, right? Security testing is not only to identify, right? It is when we are testing an application, what we see predominantly is not only helps identify what is the problem with that, but also helps the development team to understand how to securely build an application. And this we have seen a lot in our process, because whenever you're testing an application for the first time, we'll see a lot of vulnerabilities that are present, and probably we'll see about 20 to 30 vulnerabilities in the first test that is happening over there. But when we go in for that, because once we've done that, there is a process that we interact with the team. Once testing is done, you see the next cycle of testing, which could be after 3 months or 6 months or sometimes even in a year, the vulnerability count has gone significantly low. We don't find the same kind of a vulnerability, especially the critical ones, right? Critical ones will be non-existing or even higher ones, right? We'll see very low or medium level vulnerabilities that are present out there, and number of vulnerability count has gone down significantly. And this is basically because a new code has been introduced and things like that. So we are testing this vulnerability, and there's two process approach to this, right? So there's two process approach to this. We can predominantly tell one is called as a vulnerability analysis, and second one is penetration testing. Vulnerability analysis is mainly focused on the infrastructure part. Any kind of a testing in today's date can be divided into two sections. One is vulnerability analysis, infrastructure security, and second part is web application and mobile security, right? The approach, the way we go about for both of them is very different, right? Infrastructure security, what I mean from infrastructure security is there are servers, there are routers, there are switches, there are firewalls, there are desktops in a network. We will like to see what are the issues or what are the problems that are faced in those systems from a security perspective. That is infrastructure security. When it comes to web application and mobile testing, basically we're looking at the code level and the application features. So what a normal user sees when they open a particular website, right, is what we see in those situations mainly. So that is how it works. Infrastructure security is predominantly based on vulnerability assessment, right? So penetration testing is a very difficult, it is not difficult, it can be intensive on the systems, and sometimes it can break the systems as well. And predominantly they don't like the managers and the security team on the company on the client side or the networking team on the client side would prefer not to be tested in the private penetration tested out their application. They prefer a vulnerability analysis, right? So I'll come to that. I'll come to that. What you mean from that process out there. So here in a vulnerability assessment, what is that we are doing? Right? Vulnerability assessment is a testing process used to identify and assign severity level to as many security defects as possible in a given time frame. So this process may involve automated and manual techniques with varying degree of rigor and emphasis on comprehensive coverage. Infrastructure security vulnerability assessment is very critical, and it provides a lot of information about that, right? Vulnerability assessment from an infrastructure, say infrastructure security, is quite mature. The automation tool that we use when we're doing infrastructure security provides a much more comprehensive approach, right? The need for PT is also reduced because it can identify so many vulnerabilities and so many complex processes out there. It makes it much more easier to do that. But same thing cannot be said from a web application perspective, because web application still needs, right, process out there. So here there are two approaches to vulnerability assessment, right? One is a manual approach and one is an automated approach, right? Automated approach is a tool where we can specify a certain information, what is happening out there, what is the target information that we're going to specify there. And the scan is going to start working on those targets. And once the scan is complete, you're going to get a report on that. And that report is going to specify what are the different vulnerabilities that are present out there. The main difference here compared to a penetration testing, compare in a vulnerability assessment, is that in vulnerability assessment, we are not attacking the system, right? The lot of scan process is going to happen out here. What do you mean by scan is a lot of packets are sent to the target machine, right? Or it is directly connecting to the target machine. It is looking at the configuration files, right? It's looking at the configuration files. It is looking at the other processes that are happening out there. How does the application or the server or the infrastructure device behave when a certain set of signal is sent to the system? And based on that, we are going to decide about it, right? So there is no exploitation here. There is no attack happening out here. Only a scan set of scans is going to be there. And based on the scan results, we are going to identify the attack vectors. So one of the tools that we have seen most common here is.
Can I have a question?
Yes, please.
So can we say that like it is it kind of like load testing, as like, because we are sending a lot of data together to
Yes.
see the vulnerability. So is this similar kind of like load testing?
Yes, it's similar to a load testing, but the output is a bit different. Yeah. We are again sending a lot of packets here. For instance, what could happen is that, let's say an application is running on an HTTP server, right? It is going to be running on TLS and things like that. According to the latest standards, they tell is that you're not supposed to accept TLS connection 1.1 or SSL V1, V2, and V3 should not be there. The connection should be more than TLS 1.2 variant out there. So what this scanner is going to do is that it is going to try to establish a connection with the server, with your web server on TLS 1.1 or the older version of SSL version out there, and try to see and if there's a negotiation successful or not. If the negotiation is successful, at that time what it is going to do is that it is going to tell this is a cryptographic failure, because the problem why that TLS version 1.1 or SSL V1, V2 or V3 is no longer supported or advised to be used is that their cryptography is no longer sufficient enough. So if you are transmitting the communication or encrypting the communication using TLS 1.1, it is going to be decrypted. It can be cracked, right? It cannot be cracked using your laptop or your high-end server. It can be cracked by nation states, right? Because nation states like US, China, or any other Russia, they can have supercomputers which can break your encryption for that. But that is possible there. So it is not advised use for that. So similarly, there is a lot of other processes that needs to be checked from the process. So all those things that is going to be done out here. So simple way we can also think about an example is that, let me say, right, CIS continuous benchmark PDF. This is an old one, but I can get the PDF process for that. Let's say this is the center of CIS is an benchmarking, right? They talk about what are the different security metrics that need to be tested for an application to be secure, right? You can see here, so every process and every line there is here in the table of content is a kind of a test that need to be checked out there. For instance, they could tell that ensure cookies is enabled and automated and things like that. All those things need to be tested. And this is the security metric, right? And it changes for each and every kind of an application that is present on that, right? And you may be thinking, oh my God, just for running a server, I have to do all those things. And again, for let's say you're running an Apache or Nginx, there is again a different security list for this as well, right? So if you go CIS, Apache benchmark PDF, you're running an Apache CIS 2.4, then again, there's a separate list of things that you need to configuration wise that you need to be checked out there and processes, right? So these are the things that checks that is going to be done by your scanner tools, right? So this gives you a much more better control. If you think about manually, why infrastructure security is advised to be done more automated than manually is that number of text we have to do is going to be overwhelming if you're doing a manual pen testing. There's limitations to that. So that is what is going to happen, right? So how this usually in an application web server scanning tool is also there, right? They also give out a lot of information about the application and processes, but there's a limitation to that, right? Because application scanner tools compared to a network scanner, it can't check for authentication and authorization bypasses and sometimes the rate limiting mechanisms that are there implemented or not. And certain IDOR, different attack vectors that are there, there's a limitation to that. But it gives us a very base process how to go about. From a security testing perspective, we also recommend, I usually train developers as well, because they should be able to do this testing on their own before they come to us. The main reason is there is a time gap. By the time they finish the application and come to us for testing out there is a possibility of an attack in that game. And this has happened in our case. One of the clients from New Zealand, they are a medical based company, and we were in the process of finalizing what is the scope and everything. And finally they told, okay, have you started testing the application? We told no, we have not started then, but they told then we are under attack. So we also train developers or the team, application teams to use scanners out there, because it brings out a lot of vulnerabilities down, right, at an earlier stage itself. And these scanner tools are very easy to operate. Right? It is not going to be much of an issue working on this. We'll see a small demo, right? I will see how exactly we can go about working on stuffs and like that. And we'll see how the report is going to be present as well, right? So Nessus is very commonly used, right? Nmap is there in all your, it's a free tool, but it is a bit less user friendly compared to Nessus or Quali scanners. But it has it is predominantly used in penetration testing, the early stages of penetration testers. Hackers use it. It is also used in locations because certain testing applications where we go to the client location itself for testing, we are not allowed to take any kind of network scanners like Nessus or Quali along with us to test their network. There we have to manually test the things. In those cases, Nmap is very lightweight and can be used, right? Whereas Acunetics and Zap is more predominantly in web application scanners, right? So what are the three main objectives of vulnerability assessment? Is to identify the vulnerabilities, right? And document the vulnerabilities, can easily identify and reproduce the findings, right? So it basically documentation is that it will prioritize which application, which vulnerabilities should be identified, fixed first, and then what is there's also going to be POC for that, proof of concept about how the vulnerability is going there. And then again, we're going to talk about how do you fix those things, right? And how do you process should be continuous for that. So let's see a simple example. How do we go about that? So here you can see I'm running a virtual machine where I've installed a Nessus scanner out here. And this is what basically we do. So I will log into this right? We'll log into the application and I'll be greeted to a dashboard. So the process is very simple here. You'll get to do a lot of activities, but with very little attack, very little learning curve as well. So what I did here was just click on the new scan on the right side. Click here, select the type of scan that you're more interested in, right? So there are multiple types of scan. So predominantly I would go with internal PCI network scan. So this is basically what happens is that this scan is going to take care of almost all the metrics that need to be done, right? If you're a PCI company who's collecting credit card information or any kind of a thing, there's a certain set of standards, and they will specify these are the tests that need to be conducted on the network by your device. And the Nessus is going to take care of that. And all of these scans are going to be CIS compliant as well. Yeah, that is going to be not an issue of this. So whatever the processes or the different testing parameters that what we are seeing here is also going to be tested, and all of them are going to be tested and going to be scored as well. Right. So let's come back here. So I'm just giving a name, right? Webinar scan, can give her that. Then I can give a description and folder, and I can give a target name here. So this is basically here. I'm going to give the IP address, right? What is the IP address is going to be, or let me see the network settings. So this is a vulnerable machine. There's something it's called as a BWAP, and we're using this machine for scanning our process. Let me check the IP address. 167. Here it is not mandatory going to be a single IP address of that, right? For a testing process now, we are adding a single IP, but I can have any number of IP. There are test cases where I've scanned more than 150 IP addresses in a single scan. And all you have to do is, or if you have a file containing the IP addresses, you can add that file as well, right? So that's not going to be an issue. Once you're finished with this, click on Save button. And you can see here that scan has been present out here. See here, you can see there are 3 tick marks, meaning I've completed 3 scans on the same machine earlier, and I want to start scanning for this. So for this, I'm going to click on launch, right? And this is going to start scanning. You can see here, there's a process that is happening here. That's going to happen out there. That the refresh is going round and round. It means the scan is in process, and you have to go with it. This is going to take a lot of time for us, right? It is not going to be something that is going to be finished quite fast, right? Depending on the number of devices also it's going to go. There was, I think, there was in my one of the companies I worked, one of the employees complained that, scan is getting difficult and things like that, it is not difficult. There was a huge laugh, and because all we have to do is come in the morning, put up the IP address, click on the scan button and leave it. And it is going to keep on running for the time for it till it completes all the checking of that what exactly is happening out there. And finally, it is going to give us a report, something similar to this, right? As you can see here, yes, I think probably it's more better this way. And here you can see it is giving me a list of vulnerabilities that is identified in this vulnerable machine, right? This is called as a BWAP machine or BBox. This is a vulnerable machine by default, right? This is for practicing purposes that we use in our course to check, because if I do it on a normal server, I may not even get 1 or 2 vulnerabilities here. It becomes difficult for the students to identify, understand how exactly it works. So this basically is one way of helping for us in that way. All right. So this vulnerable machine, when we scan, we are seeing a different process that is happening out there. Different vulnerabilities can be observed here. And when you can click on vulnerabilities, it will show what are the different vulnerabilities, what are the issues with that, right? So you can click on them. You can see here, there's a complete description about. There's also port number, which port number that is working, what is the service it is running, and it is basically an cipher problem. It is telling SSL version 2 and 3 is protocol detected, meaning it is your SSH, the remote terminal connection or the remote is there, that is also vulnerable, and also your HTTP web server is also vulnerable out here because it is using an older version of SSL version of here. So similarly, it is you can go through a lot of this, right? And this may not be enough for you, right, in your process, because you need to document it. For that, you don't have to worry. You can always go to the report section, click on complete report. I want it in a PDF format. It will also come in a CSV, that is in Excel format as well. And it is quite useful, right? When we're doing a large network, we would prefer using a CSV as well, right? Because it will give them, because I'll show you now. It is generating a report. It will take some time. So let me see, is there an already existing report? Right.
Mr. Karthik, may I ask, interrupt for a minute?
Yes,
I have a small question that this vulnerability testing it is suitable for a application or for infrastructure?
It is suitable for both, right? So as we told, Nessus is very much in tune with the scanning infrastructure. For what I can tell you, example is that, let's say you're running. The main reason why we ask developer teams to run vulnerability scans is that from an infrastructure point of view, you can identify almost 99% vulnerability using a scan from an infra. Okay. From a web application point of view, I think you can almost, this quite varying, you can almost get about 60% of the scans out there. So, but when you're running a scan, what is going to happen is that you are having an application, it is in production. If you don't do this, you're going to be coming up with about 30 vulnerabilities or more. In some cases, we have got a lot more higher because the reporting itself goes about 170 pages or something out there. On an average, what is the problem is that there are 1,000 times if the application is having a critical vulnerability, they will have only 48 hours to fix those critical vulnerability. Because if they don't go fix it in 48 hours, they will have to shut down the application, right? And this kind of critical vulnerabilities can be identified by your scanner itself. So it makes it, by the time, instead of getting about 30 vulnerabilities, I'm getting 5 to 6 vulnerabilities, right? Which will take less time for the developers to fix, and the application is secure in a very fastest way, right?
So that is mean that I'm just giving an example, trying to picturize that scenario. Like suppose we do have an application and hosted in a cloud server or normal VPS or VPS.
Yeah.
Now, if we start this VA test and only given that VPS IP address or that particular standalone application is running, then the single scan will give all the report. It will provide the report about the infrastructure as well as the application. Like
no,
it will
no,
cover.
that's not going to happen. No. So
Okay.
for instance, so what I mean to say here is that, so if you remember, when I'm clicking on new scan here, I'm selecting the scan type, right? So here, when I'm selecting internal PCI network scan, this is an infrastructure scan that is happening out there.
Okay.
If I want to select for an web application scan, so this is the one I have to select out here. Right.
Okay.
So
two
what is going
different
to happen?
scan need to be started.
Yes, two
Thank
different scan need to be started out there. So it is not going to be a single thing. So that is why I'm telling here, right? So there is an Nessus is more preferred for infrastructure. Quali is also more preferred for infrastructure because their product in infrastructure is excellent, right? But when it comes to web application, they're not that good, right? Akunetics is an commercial application which is excellent when it comes to web application. They also have a network scan, so we don't prefer ask them our clients to use it because it is not up to the mark requirement for that one. So that is the main criteria for going about that. Just 1 second. There's an
So as you say
Give-
that
yes.
so as you say that whenever you come to the office in the morning, just turn on the vulnerability testing, so it will test like the scanning. So it will take
Yeah.
a long time. So like suppose I understand that Nessus is not that much good for web application scanner, but like suppose we are using Nessus for both infrastructure scanning and the web application scanning. So
Yeah.
can we turn on both together, or it
Yeah,
should be
that's not
separately?
it's not be an issue, right? So
Got
see,
it.
what is going to happen is that your scan time is going to take more. That's the only thing that's going to happen out there, right? So one more thing, the difference, see, I will tell you what is the basic difference, right? So I used to be in the, I used to do shooting while I was in London. So if there's a target, I can hit this target size of a pencil from a 25 meters and my bullet would hit somewhere here, right? The difference between me and an Olympic shooter is that he's going to be at that exact point in the middle. About only couple of millimeters is what the difference between me and a complete nobody and complete to an Olympic athlete. So similar situation, the accuracy of this, both the Nessus web application scanner is not that it's very bad, that you cannot use it at all. It is very good. Compared to Akunetics, there is a certain percentage drop in number of vulnerabilities identified. Because since more people have been using Akunetics for web scanner, they have more data to process run this, right? That is one scenario. And second scenario is that if you're running, if you let's say I've installed Nessus in one device, right? It is not that I can run 10 scans at the same time. It is not going to be an issue. The problem here is going to be your network card, right? Because network card, the data is being sent out. And if I'm sending a large amount of packets from the same device for 10 scans, there's going to be limitation, right? Let's say I can tell I can only do 10,000 packets per second from a device. For 10 scans, I'm dividing into 1,000 packets per scan. And if that's not going to be an issue for that. Right? So it always depends on the service server that is going to depend we are running. And again on the receiving end also, right? The server or the target machine which you are running the scan, what is its capability from a networking perspective. So all those things will pay. And your scanner is also going to take care of that. If the packets are getting dropped from the target machine and is not able to manage it, this will automatically reduce the speed of the number of packets. Probably it will might go up to 100 packets also for that second. The time taken will be much higher, but it is you can still run multiple scans at the same time, right? So for instance, I remember when I was working for one of the Middle Eastern banks out there. So there was one guy whose daily job, we have a security team, about 5 people out there. We have 4 of us are continuously hacking web application, internal web application, testing and giving a report. And this guy, one job is to come in the morning, open the scanner. He will have an Excel sheet. It is not one or two IP addresses because it's a large banking company, one of the biggest banks in the Middle East. They have thousands of systems out there, right? He's scanning about 100 or 200 machines on a single day. He put those things, IP addresses in the machine and scan and run it, let it run out there. And same thing used to happen. It is not going to be a problem. And that scanning Nessus server was also given access to us for us to run our web applications, right? From a pen tester's perspective, what we usually do is to get an understanding of how the application is secure or not, we run an SS scan to get that. But later we'll run our own process of that, right? So, and one more advantage here is that the learning curve is so less, right? Learning curve is so less for developers to focus, right? So anyone can do this and reduce their security vulnerabilities at a very cheaper cost. Cheaper cost meaning because since they are addressing it at an earlier stage of development, the cost of that security bug is going to be less, right? They can do a lot more activity based on that. Hope that cleared your question.
Karthik,
Yeah,
good morning.
good morning.
There is one question from my side
Hmm.
is there any option of setting the rules? I mean, the tool will do everything, okay?
Yeah.
But from organization to organization, will there be any sort of a set of a rule that I have a tolerance level? That means if you cross that threshold, yes, then I will consider that as a critical, I mean, vulnerability.
Yes.
Or I can set up that sort of flexibility. I don't want to be 100% perfect. There can be some room for some tolerance level. Can that
Yes.
be configured?
See, the scan report are going to be scan reports. The tolerance level is going to be at the management level, right? For instance, what happens is that if you go any organization, for in the, let's say, I'll talk about banking sector. If there's a critical vulnerability, right, the fixed time is going to be 48 hours, right? And if it's a high vulnerability, you have to fix it in 30 days, right? And if it is a medium vulnerability, it's going to be 60 days. And for a low vulnerability, you have 90 days time to fix it, meaning before the next cycle of testing begin, this is what is supposed to be there. And something which is info, there is infinite time. So it is not mandatory to fix it, but it is basically telling that there is some kind of a security policy that you're having, security best practices that is not being followed, but this will never lead to an attack. That is what they mean on that. So this tolerance is going to be set from project to project, and it depends. There are cases where this would go, this will be 30 days, this will be 60, and this will be 90, and this will be 120 also, based on the projects. So it always comes down to company's compliance requirement, right? If there is no compliance requirement, they can run the test and not do anything about it. But a lot of these companies will have some kind of an company certification, let's say like an ISO 27K certification or PCI DSS certification that needs to be done by them for their business process to continue, right? There will be a government requirement or in a payment card industry will tell if you don't comply with this kind of a test and if you fail, you will no longer be able to hold on to the data, right? And they will deny service for them. So those are the reasons why companies do take. And there is scans are going to happen scans. I cannot tell that, okay, don't show this critical or reduce the severity rating. This can be further negotiated, right? Because that is what happens when there is a dev. For instance, example is, let's say there's a server and there is a vulnerability. If this server is able to be accessed via internet, right? Anyone from the internet is able to ping this server, then the severe rating is higher. If this server does not allow any external, right? If there is no allowing any internet related connection, but I can connect to that server only using internal network. I should be inside the local LAN network for me be able to communication. Let's say this SSL version vulnerability that we are seeing here, it will go down. It will go down, right? Much more significantly. It will go down from critical, probably in sometimes high or even medium, right? Let's say this server is completely isolated. I have to physically sit in front of that system and then open and then connect. The severe rating even goes further down because the attack complexity is increased, meaning here attack complexity is low because anywhere in the world I can sit and try to compromise it. But in the second situation, I have to find a way to get inside the company physically, right? I should go inside the company and insights it in one of the systems in the network and then try to compromise it. And the finally is that it is you have to be sitting inside in front of the laptop, server itself. Meaning you have to get inside the, not only you're getting inside the company, you're getting inside the server room only, which is going to be breaching that security is going to be much different. So that's how the critical where we can negotiate for that. But from a scanner perspective, it is always going to give out this, but we'll always have to understand the complexity and then talk about it. Right.
Thank you, Karthik. Fantastic.
Right. So what are the, as we can see, there are different stages. First is network discovery. There are times, right? There are times where we will not know what are the IP addresses are, right? They will just give me a network range, something like 192.168.1.0. Please note this is a private IP address, right? So just for an example perspective, I'm giving this IP, right? There are about 254 devices, possible devices, and there are only 10 devices in the network here. In those cases, the network discovery parts come into play, where your scanner will identify if there is a device is active or not, and things like that. Once the device is active, it will like to check what are the different ports or services that are running in those systems. Right? Is it running port 80 or 443, or is it running SSH? Different ports are there, and it will look for version information also. Right? What is the version of the Apache server? What is the version of SSH that it is running, and things like that. Once it gets the version details, what it is going to do is that your scanner is going to have a database. The scanner is going to have a database, and this database will have list of vulnerabilities for a particular version of your software. For instance, let's say there's something called as the CV details, where it will have the information of all the previously existing vulnerabilities for that. So here you could see, you can see for an Apache Tomcat in the year 2014, how many vulnerabilities were identified. In 2024, we have seen one input validation, but no critical vulnerabilities. And all those things will be there. And this Nessus scanner will have that information with it, right? And it's going to do that. And it's going to give a recommendation. Once the recommendation is complete, it is the team's responsibility to fix that issue and integrate the vulnerable machine after it's fixed back to the network. And the continuously secure. What do you mean by continuously secure is that this is not going to stop. You cannot tell, okay, I've scanned now, then I'll forget about it. No, you will have to periodically keep on running things because your software is getting updated. For instance, for us, what happened was we were running a web server. We were building our own web server at that time. So there was a vulnerability in Python that we did not know about it because until GCP told you can't run this cloud machine anymore because it is running a vulnerable Python, we immediately went on to updating that particular package, right? So because you'll never know when your current software will be a vulnerability will be identified. It could happen anytime. So that is why it's very important to continuously run. Preferably, if it is a small network, you can run it every month. If it is large network, you're running out of staff and things like that, resources, 3 months is ideal, right? Going more than 3 months is not recommended. Okay. And as we saw, this is a pretty much typically a report would look like for you. Right. And this is how basically it's going to do. So where it is having a different process here, this screenshot is for a Windows server that is running and is showing there 75 critical vulnerability, meaning there is a malware engine is. It is even telling your Windows Defender it is not updated. That is also a vulnerability, right? Malware protection engine is here. You can see here that you have to update that. So all those things, it is a very fine line. That is what I'm telling. The scanners from an infrastructure perspective is excellent. I can tell about 95% of my work is web application security as an organization. I'm not telling out just by me. We as a consulting company, 95% of our work is about web application testing the application and mobile apps and things like that. 5% of them is going to be infrastructure scan, right? Even in that 5%, 5% of that 5% is going to be a penetration testing request. And that too, that is happening because there is a government or a compliance requirement telling that FPT has to be done, right? And try to break the system out there. So only those cases, but most of the time it is going to be network scan because they're so excellent. From a web application perspective, they're good, but there are certain things we'll have to do it ourselves, right? So it's always going to be, right? They'll always talk about VAPT, right? So VAPT is basically vulnerability analysis and penetration testing. Penetration testing is nothing but you are actually attacking the machine. You're using the same tool sets, right? Same tool sets that a hacker would use. Those are the things that is going to be there. But here we're identifying it and we're demonstrating the team how exactly it is happening, how the attack is going to take place and things like that. What are the so it helps them. It helps them a lot. And and we have seen it has worked, right? Because I told about the New Zealand company, the attacker could, the one we are about to scan or the test that got hacked, right? They ran multiple applications or web servers in them. The other servers were not hacked because we had actually tested it and we have actually identified vulnerabilities in that server and it got fixed. Because this was not yet identified, the hacker had an option of that, right? Similarly, penetration testing depends on the number of functionalities that are there in application. And number of tools required for testing and web application is very limited. I mean, there are a lot of tools, but what you need is very less, right? But most of the time, all you need is a browser and a proxy tool like a Zap proxy, or it could be something like a Burp proxy server is there. Only two things are required, and few Firefox browser add-on programs are required out there. Apart from that, nothing else required. Occasionally, I do use Google Chrome, and this is done basically when I'm testing a non-English web applications, right? It could be Middle Eastern, it could be in Arabic, or it could be in European, certain non-English German or some other language, or Chinese websites, companies which are running from China. Because Google has a translate option out there. So I can translate it to English, it makes a bit more. But predominantly, I use only Firefox and Burp for it to able to do it in that part, right? So there are three types of hackers predominantly. One is going to be a white hat hacker, and second one is going to be a gray hat and black hat hackers. And we have discussed this in the previous class as well. So white hat hackers are people like me who are hacking an application only after getting a consent from the target, right? The companies are inviting us, telling that you can come and pen test our activity services and see what can be done. And we have a complete legal, consent from them telling that they're supposed to hack. A gray hat hacker is someone who is doing both activities, who is hacking illegally as well as legally also is hacking out there. And a black hat hacker is someone who is going to hack for money or anything, but is not authorized to hack anything, right? That is the thing out there. It is very much important to know that without getting a written consent, even if I'm scanning, it can be considered as an hacking or a black hat or the unauthorized hack out there in some countries and some rules. So we have to be very careful, right? In terms of testing, it is a bit different, right? There are three types of testing: white box testing, gray box testing, and black box testing, right? White box testing, in this case, pen testing, we have access to everything, right? I can log into the web server via SSH. I can look at the source code. I can look at all the configuration information. I will have complete access to their network and everything out there. And this is predominantly an in-house pen tester, because what happens is that web companies which are running the servers or applications, they will also have one guy who's there in their team who is testing internally, right? Who's going to check for all the activities that are there. He will have access to everything out there. So most of the time, so it has a much more broader picture, and he will be able to even look at from a design perspective on hacking. Right? In a gray box testing, predominantly what consultants like me will be able to get is gray box testing. Here there is some kind of an information given to you. They will tell what kind of an technology stack you're running, what is the server IP address, what are the network infrastructure component perspective. They'll give you a logical diagram, but they don't give access to your network. And at the same time, you also will get certain amount of credentials as well, right? So I usually we will request two sets of credentials, right? If it's for each role, let's say there are 3 roles, there's going to be an executive role and a senior manager role and a normal manager role. We will ask 2 username and passwords for each role of it. So because for testing purposes, that is required out there. In a black box testing, is basically we want to simulate what a hacker is seeing from that perspective, how an hacker can get inside, things like that. This is the most difficult part of testing because here you don't get any information at all, except you will get these 2 things. One is the written consent from the company telling that you're authorized to pen test. Second thing is the IP address or the domain name that you are supposed to attack. If you cannot go beyond that point, right? The pen testing is always very specific on the scope. If they give you a particular domain name, and let's say when you click on that web page, it takes you to a different domain name, you can't pen test that. You have to leave it alone, or you have to double check with the developer. Is it also included in the scope out there? So predominantly you have to stick with that, and only the scope is going to be given. There is no user information. There is no information about the technology stack. Nothing is given to you. And that is how it's going to be in here, right? Black box testing, predominantly whenever you have heard about red teaming, right? It is probably black box testing. In black box testing, we also do phishing attacks, right? Where we'll send malicious emails to the customers or the targets and see how they react, right? So there was one of the things we were doing we needed credentials, right? We needed information to log in. You needed usernames of the user and things like that. So what we did was we got the office location and we did a Google map search for that office location. And we looked at all the different restaurants or cafeteria that is available out there. And we started sending them discount coupons, fake discount coupons, telling for these restaurants. Because usually if you send any random restaurant, they're not going to click on it because they think it is fake and things like that. But if you send something which is much more personalized to them, they'll think it is a legitimate mail and click on it. And that happened. That's a large organization, a lot of people in it, and we got about 5% of the people clicking on the links, and they're entering their company usernames to get the discount, right? We told them you should match when you get your coupon code. Coupon code should the IP, the ID card ID number, what is specified out there should match your in the coupon with your ID card. They enter their ID card details on there, right? And this has happened. And again, once this is done, we go back and there is an awareness training program where we tell these are the things that has happened, number of people who clicked on the malicious link and things like that. All those things. It's black box testing is much more elaborate and it does not happen quite often, very rarely. Almost 300 plus applications I've tested. Black box testing is about 10 to 15 I've done till now, not more than that. Right. So then we'll talk about the hacking phase. Right. So this is basically how an hacker thinks about how does he go about process. This includes both the white hat hacker, gray hat, and the black hat hackers. So how do they go about it? And this is very much similar to a bank heist that we'll see. I think you might have seen a lot of movies when they start off with bank heist, is that they go to the location of the bank, they look at what are the security that they're there, what is their response time, how much time it takes for the police to come in, all those things that they are going to calculate before doing that. And based on that, they're going to plan their attack based on that. Same thing is going to happen here in the hacking phases as well. The recon phase is where you're not directly interacting with the target, but you're passively collecting information, right? This could be looking at the company's LinkedIn profile, looking at the company's career web page, looking at what technology they may be running out there, because LinkedIn gives out a lot of information, right? If I can look at all the LinkedIn employees, look at their skill set, and some of them will be having a Red Hat certified engineer and they're a Linux administrator and things like that. I can shortlist, okay, this company is running predominantly Linux servers. And even I can tell what kind of and whether they are Apache, but just by looking at the publicly available information. We have to be very careful with that. That is the recon phase, right? The scanning phase is just like you're running your Nessus scanner, but here we are running a different approach, right? When we get these two information, we will get much more information about the target. And once we have this information about the target, as we saw in the process here, you could see that critical code execution vulnerability is there. Let's say this particular server is running this, right? If they're running a particular Apache Tomcat version, which is less than particular, let's say, what is the, yes, here it is telling anything before Apache Tomcat version 7.0.40, it is vulnerable. And while running a recon and scanning process, if I identify that that particular version is used, I can go on to gain access to that, right? This process goes on, then going into that. Once you gain access, you copy all the data and everything, right? Then you're not going to punch out, right? It's not like going inside, taking the data or modifying what you want. You're going to go out, and hacker would like to maintain the access to that. This is basically happens is that they might create one more user in the server with their name, username, and password, probably even giving them an admin level privilege. Right. For instance, why this is going to be important. Let's say I've hacked an admin user in a Linux server, right? And I've cracked his password and I've somehow got inside that. After 20 days or 30 days, the administrator is going to change his password. Every time that is going to happen out there. So I will have to re-hack the system after 30 days. If the vulnerability is patched, let's say in the meantime, they run a scan and they identify there's a vulnerability and patch it, I will no longer be able to hack that server out there. So in order to overcome this kind of a situation, when I hack that, I will create a backdoor for me so that I can come and go anytime of my choice. And clearing tracks is basically whenever some activity is happening on the server, there's a logs that are generated out there. So it will tell certain user ran this command at a certain time with this is going to be specified out there. And we need to clear those logs as well, because certain companies will have security operations centers, which periodically takes this log file and analyze for any malicious behavior. And in order to prevent that from happening, I'll make sure this is happening out there. Maintaining access is such a big issue, right? So in one of the organizations in US, they ran a scan and they identified their company was hacked, right? And they got to know that the hacker has not hacked their company like a couple of months back or couple of weeks back. They were hacked 4 years back, and that hacker had continuously maintained the access to them, right? Access to that network. So he was coming inside the network and going out on his choice whenever he wanted. So that was there, right? And a lot of their IP intellectual property was stolen by this hacker and sold to the competitors, right? That is there. This is the recon phase, right? When you're working as a company, you are not going to be running on the recon phase when you're doing white hat pen testing. The main reason is that the information is going to be given to you, right? You don't need to go and browse about the company application and things like that. Usually when then scope is given, the development team will sit with you and they will give complete walkthrough of the application. They will share the screen. They'll tell if I click on this, it will go to this page. In this page, we are doing this activity, and this is how the data is stored. All that information is going to be given to you, and then you're going to work on it, right? So this is how it's going to happen out there. So one more example, right? For you might ask, like one of you asked, how do I know a certain attack is critical or not critical? Now, let's example is, let's say there's one application for testfire.net. This is one of the applications we use for teaching the students how to hack a web application, right? This is a vulnerable application by default. It is not, you cannot send large amount of traffic to this website, but it's still used for training purposes. And this application is maintained by IBM. They use this application to demo their web application firewall for that reason on that. So here, right? So here, basically, bypassing a login is so easy, right? All I have to do is, I don't know the username of the password, right? And everything is going to be done here. And this is the payload, right? The malicious code that I'm using to attack the web application, and click on login, right? And you can see I've got into an admin access privilege. And you might say, okay, this is easy. This is not possible. This is possible. And it is, we don't see this happening a lot in the new applications because there's much more awareness in the development team. But the way they're validating the data is a bit odd. When they're using a MySQL or the SQL based approach for storing the user information and authentication, right? Since the attack here is very simple and the impact is very high, this is going to be in critical version, right? And if something like this does not work, right, let's say I will remove this. Now it will not work for me. If this kind of work is not there, where I have to brute force, right? I have to brute force kind of an approach to that. The criticality is going to go down because the attack complexity is more. When I do this, the attack complexity is very less. So it is very easy for me to pen test this and going about that. And this is one of the examples for that, right? One more other example is like you can see here, version disclosure. I'm using a tool called Vaplizer to check what is the version the web server is running, right? And it is telling it is using Java programming language or things like that. If you check out a very different websites like apple.com and things like that, you will not get information related to this, right? They will give a very limited amount of information. This information is not sufficient for me to pen test or trying to get access for that. So this is going to be reported as version disclosure. And this is something what a low vulnerability will look like, right? Bypassing the login credentials is a critical vulnerability. And here is going to be a low vulnerability because this could lead. Now I can focus my attacks only on Apache Tomcat applications, right? Because there are literally, if you go to a website called ExploitDB, right? This is the legal website where you get information about all the different attack vectors that is possible out there for all the devices, right? And for see here, there's a Palo Alto firewall, there's a command injection for Jenkins and things like that. That you can see in every page there are about 15 entries, and there are about 3069 pages of vulnerabilities. And each of the link here is going to give me an exploit and how do I process steps for or the payload that can be used to hack that particular service. So when I run a scan, if I get something is Jenkins 2.4.4.1, I can come here, check what is the attack vector, how to go about the process, then attack it. That is why it is important not to give information at all for us. Right? That's why it is reported. If this version is showing Jenkins 2.4.5, then it is not a vulnerable component, but still future there may be a vulnerability there, right? So what are the different places an application can be attacked or where the vulnerabilities can occur, right? The one place that is going to be there is going to be your vendor software, configuration file, and the application code, right? Predominantly where I see when I'm hacking applications or pen testing applications, these are the different three locations where I see the problem always going to lie. Vendor software is like, let's say just now we saw Jenkins 1.2.444. That is a vendor software. That is Jenkins 2. And the configuration file is like an SSH configuration file or that is going to be present in your case, right? In SSH, you might enable root login, things like that. And your application code is nothing but your web application code. You don't have control over your vendor software. If there is a vulnerability in your vendor software, you can't do anything about that code. Only thing you can do is that update your vendor software if there's a new code available out there, or what you have to do is stop the server, stop the services, right? You might have
So,
seen it. Yeah.
so I think maybe we can ask that if somebody has any question or not.
Sure. Anyone having any questions till now what we have done?
Hello, I have a question there.
Yeah.
You just mentioned now that we don't have control over
The
this.
voice is very
Okay, you
hard.
just mentioned now that we don't have control over this vendor software. But is it possible for us to scan using our own internal mechanism to scan if there are vulnerability within the vendor software? And what happens if our internal mechanism detects vulnerability? Are we supposed to inform the vendor about that, or what should we do in such a case?
Yeah. So predominantly, when you ran an internal scan out here, and if you get an vulnerability report for a particular software, the vendor would already be informed about it, right? Predominantly, most of the time, it is the vendor informing your scanner and the CV details are approached, right? So this is an what we talk about CV details. Is that? So usually what happens is that like one of my colleagues recently identified vulnerability. He reached out to the vendor telling that there is a vulnerability here. And at that time, what they're going to do is that they're going to take that vulnerability report given by them by the pen tester. They're going to cross check if there's a vulnerability present. What they're going to do is that they're going to create a patch and update the software downloaded, and they will inform the CV detail people that there is a vulnerability and please report this vulnerability in the portal. And once that is reported in the CV details portal, it will be again be communicated with these different scanning software companies like Nessus, Quali, could be other. They're going to take that information out there and they're going to start putting it up. So now in the scans, it will automatically show if a particular version matches, that is there. The number of times, it's quite rare we have seen a small vendors might not get out the patches in time, but major vendors do come up with the patches in time, right? Sometimes is that the problem is going to arise because we saw when we updated that Python version security issue was there, we updated from one version to another version. The problem there was there were certain functionalities that were there, which was used by our application got deprecated. So meaning that functions were removed from the Python library and we had to rewrite a lot of code. In those situations, the companies usually tell, okay, let's take time, let's not update it. And then we'll write a program for rewrite the application code for that. And then we'll update it. And that is where, Equifax about 140 plus million SSL social security number was stolen because they were running an outdated version of a software that it was outdated for more than 6 months. They were still running it because the code depended completely on the particular vulnerable patch code, and that is there. So if that fixed that vulnerability, there was nothing a major. The hacker did not come up with something very unique way to approach. He took all an already existing vulnerability. He went to exploit DB or something like that and took it and take the data out from there, right? So it usually you don't have to worry, but you have to worry about updating it because there are cases where the system might not work the way it's supposed to do. And in those cases, you will have to think about how do you go about it, right? And there are, in some cases, what happens is that we have seen that there will be certain applications that they are going to sunset it another 6 months or 3 months time. And for the compliance requirement, they will have to fix that. And they tell this application is not worth that much amount of developers' time because we are in closing stages and very few people are using. In those situations, we do come up with other solutions where they are going to be putting it behind and putting it into a separate network and controlling who can have access to that network via the firewall. So increasing the complexity of the attack and reducing the impact of it, right? Whereas your application configuration and code, that's there, right? So there are a lot of things that happens out there, but when you understand security from a process perspective as well as in technical perspective, it makes more sense. It makes things much more easier for you, right? So that is where this webinar is also focused on. Right? Yeah, let's come back. So we have
any other question?
Okay, I want to ask a question. Yeah, concerning
yes.
when you were using the payloads. So I want to
Yes.
ask, do you run a script before applying that payload, or the payload is a default? And the password you were using, is it just a random password that you were using? So that's what I want to ask.
No. This is if you're asking for this particular part, this is not a random password, and this attack is called as an SQL injection attack, right? So what is basically here, it works in a different way. When you enter the username and password, right, it is actually sending to the SQL database, selecting whether if there's a query that happens, if this existing or not, it is going to give a true or false answer. The application server or the web server, MySQL server, is going to give a true or false answer for that, right? If the answer is true, then the username password is right. If the answer is false, the credentials are wrong out there. So, but when I'm giving 1+1, it is always going to be true, right? When we're looking at an SQL injection attack, this makes more sense, right? From explanation, there is always a reason for a particular payload to be done. Running a script is basically sometimes when the attack complexity is high, where we'll have to do a lot more things for getting the process to understand. At that time is when we run the scripts out there, right? Basically, the packet that is sent from the hacker machine to the server, the packet need to be changed. The value of the packets and things are there. It is going to be changed here or modified here. In those cases, we will need to run a script, right? So it is predominantly depends on the attack vector, whether you're using a pre-existing payload or a script, depends entirely on the attack vector. Yeah.
I think most of these things
Yes.
we are going to cover in our main courses. Correct me if I'm wrong, Mr. Karthik. But
No, yes.
and we do have a broader, angle to cover in our main courses because the timeline is much more we have, so we can showcase the every needs and deeds. But okay, yeah. If anyone's don't have any questions, so we can continue.
Yes. So for instance, let's say for the simple attack vector, what we saw now, right? It is just, this is the attack vector payload we are using. Why this payload is working, it will take about an hour's time to explain. Right? I will have to explain how SQL is working, how the PHP server is interacting with SQL, and what exactly is this, right? So that is covered in the main course, why this attack is working. And there, I think your main course here, there's much more emphasis on the lot of web application itself, and we go with cover a lot of vulnerabilities there. So here,
All
so
right,
now,
thank you very much.
welcome, thank you. So now, when it comes to finding out vulnerabilities, the vulnerabilities that are configuration related or related to your code, you can modify anytime and make changes to that and fix it. And the vendor software vulnerabilities is where you will have no control over that. But predominantly, most of the time, there will be a secure version available out there that you can run it, right? In some cases, the newer version of the software may not be suitable for you. In that time, same thing happened for us, and there was an administrator try to tell that let's try to push it for a couple of days, and GCP told no. If you don't fix it in another one or 2 days, if you don't update in 2 days, we are going to take your server out of the network, right? So then we didn't have an option at that time we had to focus on things like how do we fix it and stop all the activities, put all the developers on the new tool and things like that. It was not a major tool, so it was not big of an issue. But if it is a much more larger tool, it can be very difficult, right? So that is there. But this is happening, right? The pen testing is happening at the later stage when the application is built, everything is done, and that is going to be done out there. The cost here is still high. The cost here is still high. So if we identify, let's say that I remember in a long time back, they tell if you identify a security vulnerability at the design phase, it is going to cost you $5. If it is identified post coding phase, it is going to cost you about 500. If it is going to cost you around after goes into production, goes to cost you around $5,000. But if it is not identified at all, and if it is exploited, there'll be the cost is going to be very high, right? For instance, certain companies like Target lost billions of dollars in revenue because people lost trust in the application, that they can store the data. Those people stopped purchasing their products on their website for a long time. And there was a company which entire data was deleted, right? Nothing was left, and they've lost everything and they had to close the company, right? Because that did not identify as well. So it is always an emphasis, right? Emphasis on identifying the vulnerability at an earlier time itself. How do I go about going out, check this vulnerability and go into go process with that, right? So the most earliest place where you can identify the vulnerability is going to be in the design phase. And in the design phase, we introduce a concept called threat modeling. And this particular approach, right, in threat modeling, here you're involving a lot of activities where you identify, okay, these are the different attacks that is possible out here, and this is how I should go about. So this should be the mitigation that should be present out there, right? Let's say we have something called there's a login functionality. Login functionality is present out there. What are the different attack vectors, right? As a pen tester or a hacker or if someone who is a security guy, I do know what are the different vulnerabilities that could be present out there. So when I sit with the development team, we analyze the application functionality, and then we'll come up with a list out there where it specifies these are the vulnerabilities that is going to be present out there, right? For instance, I usually tell for the process is that just give me a second. There's usually a checklist that is followed by us, right, for each and every functionality. And there is for each and every kind of a functionality, there's different types of. For a login functionality, these are the different attack vectors that are possible. That's the bare minimum amount of tests we have to do. Based on this, then we can go and tell these are the attack vectors. If you have a login page, these are the attack vectors out there. What is your security measure, right? If the developer knows and there is a discussion that happens out there. So here we're going to talk about define the security requirement and identifying the likely threats out there, right? And then we are going to assess out there threat assessment, because we have to see what is the concept that is the which is critical vulnerability, which is not so critical vulnerability, and things like that, right? For instance, concurrent login is also a vulnerability. For instance, I can use same username and password multiple users can use to log into the application. Similar to something happens with your Netflix account, right? You can share your password and only one device can be used at a time, or two devices can be used at a time. In some cases, in some situations, that is not an ideal thing, right? It varies. It varies based on the application. It varies based on the data, right? If it is, let's say, someone is accessing a criminal record in the police department or crime branch or things like that, only one person should be able to access that file. No other person should be able to access that file simultaneously. And those are things out there. So there the assessment is going to be done. Then we are going to give a threat mitigation for the same, right? So what is the process, how to do with that? So what is the mitigation? Let's say there is a password is weak password, right? They are not mandatory telling that a password should be of certain length. So we can enforce that requirement telling that password should be minimum 8-character long password, and it should be an uppercase, a lowercase, and the number should be present, right? And it should also make sure that password is not stored in their company website, and only the hashes of the password is stored. Right? That is also a security metric, because it is illegal to store the password in plain text. Because if you remember, whenever you tell you forgot your password, you'll always get a reset link. You will never get your old password, because companies, they don't store your passwords at all. They identify your password during a process called hashing. That when we understand hashing, we'll be able to understand that better. Your password is never stored. If you're storing a password, then it is a vulnerability. It should not be done, and things like that. And finally, the confirmation of threat mitigation. So let's say you have identified the threat, you have given the solution, and you have implemented the solution out there. But how do you know whether that threats does not exist? It has been mitigated or not. And this is basically done by PT at the end, right? PT is the one way of verifying the penetration testing that nothing is an issue here. That is how it goes. So now we have understood that threat modeling is important. We identify a process for that. But the thing about network security or infrastructure security or cybersecurity is it is a multi-layer approach. It is like an onion, right? You should have multiple security measures for the same securing the same resource or the data out there, right? This is similar to telling that you have something valuable and you keep it in your safe, right? Just because you've kept your valuables in the safe, when you're going on a vacation, are you going to open your gate, your door, and your bedroom door open because the valuable is there inside the cupboard, but it is inside the safe? You don't have to worry about it, right? But we don't do that. We still lock the rest of the things out there, basically because we wanted to make it more difficult for the thief to get inside the data, right? Or get access to your valuable information. It is not only going to make it more difficult for him, it is also going to give you more time to respond to an attack success. Right? It is very critical approach out there, and it is always a layered approach. Yeah. So before we go into that deep, defense in depth, we'll understand few other devices that are important from us from a security perspective. How do we make our infrastructure more secure? Right? How do we make our infrastructure more secure? One of the first line of defenses that we see, and this particular from an industry perspective, firewall administrators is pretty saturated, but it is still a mandatory tool that is going to be used, right? So what is a firewall? So firewall are devices or programs that control flow of a network, traffic between network and host that employ different security posture. So here I can tell is that firewall is going to manage that this is not supposed to have. It is going to tell, let's say, if there's a server out here and there's a firewall, I can now tell which person can access this server and which person cannot access this server. I can tell allow A, but block B, right? This can happen out there. I can do a lot of other things as well. Not only that, allowing a particular machine, I can even tell allow A only on port 80, meaning only allow them to connect on an HTTP, because there's HTTP web server running here. They should be able to go with that part. Predominantly, when we're talking about network firewall, if you know OSI model, right, network firewall works on transport layer, network layer, and the data link layer. Right. So what it basically talks about is port number, IP address, as well as the MAC address. These are the criteria that is used for deciding which device is going to be allowed or not. So I can tell I will allow a particular IP address only on this particular port, subject to condition that device source machine is going to become from a particular MAC address, right? MAC address is rarely used for filtration. It is usually used for administrators, right? Because administrator will have a fixed system from where they will be connecting to the server to monitor or make changes to the server. So I can tell that only when you're connecting from this server, from this desktop, you can access my device, otherwise you can't access, right? And there is multiple ways of implementing firewalls, and one of the firewalls is a network based where it is on the edge. So meaning when your company is connected to the internet, right, on the edge of the internet is where your firewall is going to be there, and internally it is going to be allowed, right? Before any packet that is coming inside the network and going outside the network is going to be monitored, and it is going to be allowed by a firewall. Right? Even your servers like Linux server will have a built-in firewall as well. So meaning this is a second two-tier second. There's one firewall on the network. Then again, when it connects to the server, there's one more mini firewall inside that. So here this is layer one security. There's a second layer security. Like in large organizations, they will have multiple firewalls and one for each network segment. So that let's say there's a marketing department and sales department. They will have one server at the entrance of the net when it is connecting the internet, but they will also have a firewall filter between the networks as well. So meaning to make sure the marketing department cannot have access to the sales department, to make sure for those things. And the most common used firewalls today we see is Palo Alto, Checkpoint is one software, and you have Cisco also is very famous for that. But they're not Cisco, even though they're the number one in routing and switching. In firewall, they still struggle, right? And firewall D is something is a Linux based. It's a free. It comes with every Linux, and you can configure a Linux network related process with that. Right? An application firewall works on layer 7. That is your WAF. That is your application layer. So this is basically it. We can also filter IP address, port number, and process for that. But there's a different firewall for application, because the network firewall, if I do the same activity on the WAF activity or application layer, network firewall throughput, it will become very slow because there's a limitation to the number of tests that needs to be checked for each and every packet. And a WAF takes in a lot of process, right? It is much more In terms of processing power, we will need much more capability for a WAF server because the amount of test it has to do is going to be there. So if you remember, we were able to bypass that, right? So how did we bypass? We just gave single quote or 1 equals to 1 dash dash and dash. If this kind of a payload goes through a WAF, it will immediately block it, right? It will immediately block it. It will not allow it to pass it to the server at all. So there's a lot of attack vectors that is going to be prevented using the WAF. In some situation, let's say this is a critical bug, what we saw. So it will take time for us to implement the patch for that. In those situations, we recommend put a WAF in front of it. It is called as a virtual patching. We are not actually patching it. It's called as a virtual patch, where it will give the developers some time to fix it. Right. And it is going to be quite intense. Amount of payloads it can check is going to be quite intense. For instance, a network firewall will check for every packet that is coming in. It will check the source address, destination address, what is the source port and destination port, and what is the MAC address. Right? MAC address is not going to be useful much time, but most of the time it is looking at the port numbers as the IP address and the two categories that is going to check. Whereas if you go right for a WAF, it's going to be much more difficult. For instance, this is a possible list of payloads for one particular attack vector called XSS, right, which we'll see. And every line here you can see is a separate payload. When any input that is sent from your browser to the server, it is actually checking through all this. Is it matching? Is your whatever the data? Let's say if I'm entering the username as Karthik, and this it is going to be cross-checked with everything that is going to be here. And this is just for a single attack vector. For multiple attack vectors, it's going to be very large. So it is going to be quite CPU intensive. So WAP is very important. Okay. From a design perspective, defense and design perspective, a large good quality application will have a network firewall first, right? Firewall is going to be network here. Then it will pass on to the WAF firewall, right? Then probably it will pass on to an antivirus server. Then probably it will go the actual server before going to that. You'll never, before it reaches a lot of filtration process is supposed to happen. And firewall is able to do all those things. An application is in Imperva, Encapsula, and Cloudflare are quite common. And we'll see a lot of times Cloudflare is used because it's on the cheaper end, right? They do provide good security, but for small organizations, small applications, Cloudflare is much more feasible because they charge about $20 or $25 per month for a certain amount of traffic. If it crosses beyond a certain amount, they charge more, but it's totally possible. Whereas Imperva Encapsula is about much more larger organization. When you're running a lot of software applications, Imperva makes more sense on that. Acunetics and things are there. Right. So this is what a firewall does. And there's something else also called as intrusion detection and prevention system, right? So what does this device do? This device is going to look at the behavior of the network, right? There is a limitation to a firewall can do. It can only check if something matches a rule. Yeah.
Sorry, Mr. Karthik, I got two message.
Yes.
Because it is already we are on the verge of 2 hours. Is
Yes.
it okay with all other students that if we continue from the next weekend, if Karthik is okay with that?
Yeah, I think I'm almost done, but anyway, I will take about 5 minutes more.
Okay. Okay.
Yeah. So IDPS system is basically it will monitor the behavior of the network, right? So it will check for detect. Let's say if there's a large amount of traffic is going out of the network, so on an abnormal time like night 12 o'clock or things like that, then it is going to see that is an issue. Then it will alert the administrator, right? So this is basically, it is a detection system and it will prevent. So it will prevent, like it will take action like alert the administrator or block the device where the attack is coming from, or stop the communication to the target machine, right? Or change the security environment, meaning that is it will have the ability to modify the firewall rules. And sometimes in an attack, modify the attack content. This basically deals about removing unwanted information. Like in an email, there may be a malware attached. It will remove the malware out of it and then forward the email to the system order. So basically, what is the difference between a firewall and IDPS, right? Firewall, let's say when you're going for an exam center, firewall will basically talk like a guard who's going to check for you an ID. If the ID is valid, it's going to allow you inside the exam hall. That's how it works. A firewall particularly does. An IDPS acts as a proctor, right? The proctor is someone who's constantly checking everyone's behavior, what is happening, are they doing any kind of a malpractice or cheating is being done by them. And if he identifies certain cheating is being done, he will take the necessary actions. So that basically that is how these two devices are going to be present. So now this is where the difference in depth comes into play. Security is always a multi-layer approach. You're always adding multiple security features. And here we are also considering human negligence as well, right? A lot of times the users, they do is they will click on links or they might try to copy the data when they're leaving the company and things like that. How do we overcome this kind of thing? Right? So now here, how do we do is that one of the main thing is coming up with policies, right? Setting a password complexity is one of the policies. Telling that there's a bring your own device. You cannot bring your devices. If you're bringing your device, there's a procedure that needs to be followed, right? And providing them with the awareness, like what are the things, how to identify a spam, how to identify phishing mail, what you should do and what should not do. Don't buzz, you use your access card to allow someone else inside the company. Ask them to use their access card, right? Physical security, right? Locking your server room is very important. There are cases where people have walked inside a company, took the server and walked out, and this has happened in real time. And application security and computer security is right. You know, how do you secure a server at an infrastructure level, right? And also, how do you secure an application? So all those things is going to be considered. And how do you secure a network? So where are you going to place the network firewall? Where are you going to place the WAF firewall? Where is going to be an IDPS going to be present out there and things on there? Not only the critical infrastructure, although the normal infrastructure like your desktops and processes, that is going to be taken into consideration, right? Making sure that no one can access, put a pen drive into their laptop or things. If they put a pen drive, what is going to be happen out there? What kind of an alert is going to be generated? Who is going to be informed? Is there any kind of an punishment for that? All those things needs to be taken into considered account here, right? So that is what the difference in depth is going to be. Security is always a layered approach. And so it make it more difficult. The more layers they are, make it more difficult for an attacker to get inside the network. Right. So that's it. Right. That's it. So any questions? Any questions, guys?
No,
Are
no,
you
So
able
for
no.
the
to?
discussion is
Yes. Yes, ma'am.
so for the discussion is like pretty interesting, but hopefully wherever the main course will gonna happen, then we could get more visualization of each part, which
Well,
can make it clear to understand everything.
Yeah.
Hopefully that.
Yes. Hopefully, yes. Because when it comes to web application security, there's a standard called WASP that we do, right? And OWASP top 10 that we cover. So most of the critical vulnerabilities that are there in a WAS process like broken access control, cryptographic failure, injection, security mix configuration, and things like that is going to be covered out there. So almost all is going to be covered. Right. Only thing that we don't cover from a course perspective is serialization and deserialization, because that is rarely used. It's a bit more common from a short span of times. But most of the vulnerabilities are covered, which is not there in WAS top 10 also. So that is there. And we also give out a lot of other resources which will help the student understand the process.
See,
Do we have to know any language like C, C++, Python, or
No,
anything
no,
to?
no,
Got
no.
it. Thank you
So this is a kind of a course where you can, even a fresher with a little bit of IT background, will be able to understand. That is why the initial stages of the course is having a Linux and other things out there. Yeah, man, please go.
yeah, the thing is, this particular session which we are today trying to cover in our main course, that we'll cover within 14 days. So Karthik will have much more, flexibility to demonstrate every in minute level as well. But the issue with this internship program that we need to cover and try to give a holistic idea about a particular topic in a day. Sometime we could not cover, so sometime we move to the next day as well for the continuation. So here the main agenda to create awareness, but when you going to in the main course, our agenda is to make sure our students are well trained on that particular topic. Any other question?
Yes.